In this problem, we are going to show that pi is greater than 3.05 without the previous knowledge of the actual value of pi of 3.14. Notice that I draw a circle because in geometry, pi is involved in finding the area and perimeter of the circle. The formula for the area of a circle is a equals to pi r squared, and the perimeter is going to be 2 pi r. For the simplicity of this problem, I'll be using the area as the perimeter. So notice that we do not want the r squared here, we only want pi. So to remove the r squared, we can just simply set r as 1. So now we have a unit circle. We want to show that the area of this circle, which is pi, is greater than 3.05. So this reminds us, 3.05 can be, or approximately, the area of another inscribed polygon inside the circle. Because we can think of 3.05 as more like a range. If we can prove that there exists a polygon inside a polygon, inside of this unit circle, that has an area greater than 3.05, since the area of the inscribed polygon will be less than the area of the entire circle, then the proof is complete. Now the question is, what is the value of n here? Because we know that the inscribed polygon will be a regular n-sided polygon. So if you just test like a square, well, if you test a square, you'll find out that the area is much too small. Because since we know that the radius of this is going to be 1, well, if you divide the square into 4 sections, then the area of this section will just be 1/2. So the 4 of these isosceles triangles combined will give us an area of 2. But then 2 is smaller than 3.05, so that's not what we want. So instead, we have to think about a different one. Notice that all polygons can be broken down into equal isosceles triangles. You know that it's isosceles because 2 of the sides of the triangle are just going to be the radius, which are equal. So what is the angle of each of these triangles? Well, for 3.05, we just actually want the smallest possible angle that we can work with. Because the smallest possible angle means that there's going to be more triangles, meaning that the inscribed polygon will be much larger. Because 2 right now, if you have n equals to 4, it gives us a square, right? So the square will be much too small. Well, you might think it's 30 degrees. And in case of n equals to 12, we know that the angle theta equals to 30 degrees. However, this is not the smallest we can get. We can even work with 15 degrees. 15 degrees can be used because we know that by the double angle formula, we know that 15 degrees is half of 30 degrees. So if you have an angle that has, if you have a triangle that has 15 degrees, that's one of the angles, we can manipulate the triangle to get a 30-degree triangle. So when the angle is halved, we know that there must be twice as much sides. So n equals to 24. So here we have a 24-sided polygon. We don't have to draw this entire thing, just draw one of the triangles. So the triangle will be really small. And we can think of it just like this. We can call this as point A and point B. Now we want to find the area of this triangle. And we already know 2 sides of this is going to be 1. We can connect AB. And then we can set AB as x. Or actually the x we can set in this case is going to be the height. Because we already given OB or OA, they can be the base. So we can construct the height. So we can call this point as C. And we let AC equals to x. So if you let this equals to x and this is 15 degrees, well, how do we construct a 30-degree angle then? Because our goal is to construct a 30, 60, 90 triangle. Well, to do that, we have right angle here. So we can set a point here as D, such that AD equals to OD. With isosceles triangles, AOD, meaning that angle AOD equals to angle OAD, 15 degrees. So by exterior angle theorem, EAT, you know that angle ADB equals to 15 degrees plus 15 degrees equals to 30 degrees. So now we have 30, 60, 90 right triangle in ACD. So if you let AC equals to X, that would mean that AD equals to 2x by the ratios. And then CD will be square root 3x. And then we know that AD equals to OD. So OD is also going to be 2x. And then we can apply the Pythagorean theorem on triangle AOC. So we will have x squared plus 2x plus square root 3x squared equals to 1. 1 squared. 2x plus square root 3x is just going to be the length of OC, and x is AC. So AC squared plus OC squared is OA squared. Now, with this in mind, we're going to simplify this. Expand the parentheses. So we'll get x squared plus 4x squared by a perfect square formula plus 4 root 3x squared plus 3x squared. And this we know will equal to ax squared plus 4 root 3 x squared equals to 1. So the value of x here is going to be 1 over a plus 4 root 3. We can simplify this. And for this, we know that x squared is equal to 1 divided by a plus 4 root 3. So x is going to be the square root of this. Square root of 1 over a plus 4 root 3. We can rationalize the denominator, times both sides by a minus 4 root 3. So then this will equal to, after simplification, this will equal to 8 minus 4 root 3 over, by difference of squares formula, this will equal to 8 squared minus 4 root 3 squared, which is 64 minus 48, that's 16. We do not want the nested radical here. So to remove this, well, we know that we want to construct a perfect square instead of the square root to cancel out the square root. So how do we break down 8? Well, 8 can be represented as square root 2 squared plus square root 6 squared. So if you observe this, this will become square root 2 squared plus square root 6 squared. We have a minus 4 root 3 here. So it will become minus 4 root 3 as our 2ab in the formula. 4 root 3 is actually just going to be equal to 2 times square root 2 plus square root 6. Because square root 2 times square root 6 is square root 12, which is 2 root 3. So 2 times that is 4 root 3. And divided by 16. So this will equal to, at the end, after simplification, we'll get that this equals to square root 6 minus square root 2 over 4. Now we have the value of the height. So the area, you can call this as S triangle AOB equals to 1/2 times base OB, which is 1, times square root 6 minus root 2 over 4. This is going to be times. So it'll become square root 6 minus square root 2 over 8. So we know that there are going to be 24 of these because n equals 24. So the area of polygon, we can just call it, would equal to 24 times square root 6 minus square root 2 over 8. Which will equal to 3 times root 6 minus root 2. But then how do we find the value of 3 times root 6 minus root 2? Well, if you find a new page, well, if you have here 3 times root 6 minus root 2, well, notice that our goal is just to prove that 3 times root 6 minus root 2 is greater than 3.05. But then it's hard to work with here because 3.05 is not a multiple of 3. However, we know that from common sense, 3.06 is greater than 3.05, right? And 3.06 is greater than, it's a multiple of 3. 3.06 equals to 3 times 1.02. So our goal is to find that square root 6 minus square root 2 is greater than 1.02. And how do we do that? Well, we can take approximations. We know that square root 2 is going to be smaller than 1.42 because square root 2 is approximately 1.414. And then square root 6 is going to be greater than 2.44. So if you have a general case, for example, we can say A1 minus B1. Well, if you have there exists A2 is less than A1 and B2 is greater than B1, then obviously the difference between A2 and B2 is going to be smaller than the difference between A1 and B1. So A1 minus B1 is greater than that of A2 minus B2. So in this case, we have square root 6 minus square root 2 will be greater than 2.44 minus 1.42. So square root 6 minus square root 2 greater than 1.02. So with this in mind, we know that 3 times square root 6 minus root 2 is greater than 3 times 1.02, which is 3.06, which is greater than 3.05. And now we know that the area of the circle, which was pi, this is greater than 3 times square root 6 minus root 2 equals to, which is greater than 3.06, which is greater than 3.05. So the proof is complete, and we have pi is less than is greater than 3.05. So that is how you solve this problem.